monoatomic gas undergo a thermodynamic process in which internal energy of gas varies with the volume U equal to A V B. So there's the internal energy. Intensity of gas, it varies with volume like this. With volume as U equal to A V to power of B. Find molar heat capacity of the given gas. Okay, what you are going to do now? It will vary as a intensity can vary, even work done will vary. So anything can happen. Slowly, I'll push you to the higher levels. Huh? Slowly, I'm dragging you to higher levels. So we don't have anything so directly. We know intensity is a function of temperature, U equal to alpha T. That's all, no? In any process, intensity, what is alpha? Or we know intensity should be R by gamma minus 1 into T. Let n equal to 1 so that so we can make the problem very simple. R equal to, so this R by gamma minus 1, let me call that as alpha. So shall I write this is, so this will become A by alpha V to power of B. Just now we had a discussion temperature equal to, okay, we'll do one thing. I'll be needing the dV, no, in this, so let me differentiate this. dA equal to A by alpha B to power of dV. Okay, there's the value of dV. So let's go for work done by the gas, P dV, 0 to delta T. So this should be equal to nRT or RT by V. So dV is equal to dt by alpha AB V to power of B minus V. Look at the substitution. No, this is equal to, so what we can write it as like a T, V should be eliminated, no? Okay, I think let me solve it this one. R T alpha AB also will come. All constant terms R alpha AB, then T dt. Here it will be VB will be there. So VB, what we can write alpha T by A. Next step. VB, what we can write alpha T by A. So A get cancels, alpha get cancels. So what will be finally? A gets eliminated, alpha gets eliminated, T gets eliminated. So R by B is what? I'll take outside. So this is 0 to delta T. So what is work done by the gas? RB by delta T. Okay, let's go for, so what happened alpha all? Okay, let it be, no problem. Let's see in the end what we can do it. So molar capacity is equal to C equal to Q by delta T. Delta U W by delta T. CV, what is W? This will be R by B So finally, molar capacity equal to how much? CV by R by P. Let even intenji vary with any quantity. Sir, intenji varies with work done. Let it be, no problem. We can manage. Whatever equation, let him give. So who are the best friends will help you? First law of thermodynamics is one. Molar capacity definition. Ideal gas equation. Okay, are you seeing this? I'll just put so that will be easy for you. Huh? The replacements what we are doing. Okay. Intenji as a function of volume, intenji or anything. Huh? So these are the types of questions what you can expect, and student must be in a better position to analyze all these things. Here also, B you can make it negative, positive, whatever things you can change it. Again, as you change the value of B, you let B equal to 0. What do we get? B equal to 0. Anybody? A and B are constants here. A and B are constants. Okay, if B equal to 0, isothermal process. B equal to 1. Anybody wants to comment? B equal to 1.
Isobaric.
Isobaric. So as a monatomic gas, no? So isobaric process monatomic gas, 5R by 2. B equal to 2. Three R by 2. Okay, 2R. So some general thermodynamic process. B equal to -1. 3R by 2 minus R by 2 will be R. So general thermodynamic process. B equal to -1. If B equal to -1, B equal to -1. So TV equal to can we make it 0? Now what should be the value of B to make it 0?
-2/3, sir.
-2/3. This will become adiabatic. Are you? No, can we make it negative? Any value? Let me introduce that also. Anybody suggest some any value? Negative.
-1/2.
How much you'll get? This one.
-1/2, sir.
Okay, this one. Molar capacity.
That is also -1/2.
Minus R by 2. Huh? Okay, now you see this. Engineer, no? So engineer, what happened? You should design the equipment which will control the value of B. Finish short. I just written same symbol so that you can think a lot. So you should not get confused. Sir, like he has given sir formula like this, what to do. Better remember this one you can manage very easily. Huh? Or will conclude all thing. Everything I'll make it a formula in the end. Huh? Because if I give formula in the beginning, you'll start thinking formula. In the end, I'll give a very generalized formula. All these numericals you need to solve. You can directly take help of that formula. Let me bring that in the end. No, because let me make you think now. Okay, now molar capacity should be a fixed value. Will I agree? Anybody wants to comment? Or can it vary with pressure, temperature? No, it can. It need not be anything. Molar capacity, I said -infinity to +infinity means it can take anything. No, there's no rule that it should be like this only. Okay, let's take some situations. let me write that explanation question so that you'll get confused. An ideal gas